morning everyone. My name is Dr. Kusumita Kundu. I am an assistant professor of chemistry in SBI. Okay. So we are continuing the topic of UV spectroscopy. In the last class, we have studied about the electronic transition. So the possible electronic transitions were sigma, sigma star, pi, pi star, n pi star, and n sigma star. Now, if we write the energy order, sigma sigma star requires the most amount of energy, then n sigma star, then pi pi star, and lastly n pi star. Okay. Now, as we know that energy equals to hc by lambda, that means energy is inversely proportional to the wavelength. So, if this is the energy order, then the wavelength order would be sigma sigma star less than n sigma star less than pi pi star less than n pi star. Okay. Now, the sigma sigma star corresponding wavelength comes in the region of less than 200 nanometer. Okay. We are comparing only between sigma sigma star and pi pi star because in between these four transitions, only sigma sigma star and pi pi star transitions both are spin allowed and symmetry allowed. These two transitions are both spin allowed and symmetry allowed, while by n sigma star and n pi star they are spin allowed but not symmetry allowed transitions. They are symmetry forbidden transitions. That is why we are only comparing between sigma sigma star and pi pi star. Now, from the energy order, we can say that sigma sigma star requires highest amount of energy, while in the wavelength order it requires the lowest. It will show the lowest wavelength in the region. Okay, in the wavelength region. So corresponding sigma sigma star, the corresponding wavelength is less than 200 nanometer, while the corresponding wavelength for pi pi star is greater than 200 nanometer. But UV region starts from 200 nanometer to 400 nanometer. UV region starts from 200 nanometer to 400 nanometer. So from this we can see that sigma sigma star doesn't fall under the UV region. That is why sigma sigma star is UV inactive transition. UV inactive transition. This is sigma sigma star transition because the corresponding wavelength of sigma sigma star is less than 200 nanometer and it doesn't fall under UV region. That is why sigma sigma star is UV inactive transition. While the pi pi star, the corresponding wavelength for pi pi star transition is greater than 200 nanometer. That means it falls under the UV region. So pi pi star transition is known as UV active transition. Pi pi star transition is known as UV active transition. Okay. So sigma sigma star is UV inactive and pi pi star is UV active transitions. Now we will do some examples. Okay. First example is CH3CH3. Second, let's say ethylene, and the third one is acetaldehyde. Okay. Now, in case of example 1, in case of molecule 1, what is this? This is ethane. So, the possible transition would be sigma sigma star because here is no pi bond. So, it will show only sigma sigma star transition. In molecule 2, this is ethylene. So, there is both sigma and pi bond present in that molecule. So, it will show sigma sigma star and pi by pi star. Both the transitions will be same here. Okay. And in case of molecule number 3, it is acetaldehyde. Acetaldehyde, there is the structure of the acetaldehyde is like that, right? So the possible transition would be sigma sigma star, pi pi star, and as there is a lone pair on oxygen, then it will show N sigma star and N pi star. Okay, so all the 4 possible transitions will be present in case of acetaldehyde. Now, in between all the transitions, you have to say which one is UV active and which one is UV inactive. In case of ethane, only sigma sigma star is present, so it will be UV inactive transition. Okay, so it will be UV inactive transition. In case of ethylene, sigma sigma star is UV inactive, while pi pi star is UV active transitions. Right? Pi pi star will be UV active, and in case of acetaldehyde, this sigma sigma star is inactive, UV inactive, and it is UV active transitions. Okay, so that's how you have to find the possible transition present in any molecule and which one is UV active transition and which one is UV inactive transition. Thank you so much.